Now let's move on to 2.2, which is about quantum mechanical model. So the syllabus that you need to learn about 2.2 is you need to define the term orbital, explain all the 4 quantum numbers of an electron in an orbital, and sketch the 3D shapes of s, p, and d orbitals. By definition, atomic orbital ni, if you ada atomic model where you ada nucleus and ada electron yang mengelilingi nucleus, so basically orbital is a 3D region in space around the nucleus where there is a high probability to find an electron. Okay, and basically nucleus ni is surrounded by an electron cloud, and also electron actually they occupy the 3D space around the nucleus. Okay, the next thing that you need to know about quantum mechanical model is about quantum numbers. First of all, you need to know what does it mean by quanta. Quanta is actually a discrete amounts of energy. Okay, so bila electron dekat ground state, kan bila dia absorb energy, dia akan excited kan. And also bila electrons at excited state, bila let's say dia fall down, dia akan release energy. So that amount of energy yang kita describekan dia as quanta. Okay, alright. And also bila let's say you ada nucleus and also you ada electron yang orbiting the nucleus, okay, the positions and orbits of electrons in an atom are referred to as energy state. This energy state you boleh describe dia by 4 quantum numbers. So apakah that 4 quantum numbers? You have N, you have L, you have M, and you have S. Apakah itu N, L, M, S? N adalah principal quantum number, L adalah angular momentum quantum number, M adalah magnetic quantum number, S adalah spin quantum number. So nanti kita akan discuss all of this later, but I'm pretty sure that you have met the principal quantum number before. N kan adalah energy level or orbit of electron yang mengelilingi nucleus. So the rest of it you haven't met yet, but we will discuss about this later. Alright. First of all, let's go through about the first kind of quantum numbers, which is the principal quantum number, N. Okay, we have met this before. Okay, actually N adalah energy level and size of an orbital. Okay, so if let's say you ada atom, hydrogen atom, this is the nucleus and ada orbit yang mengelilingi the nucleus. So the orbit yang mengelilingi nucleus tu ada energy level dia yang masing-masing. Okay, and also if you translate it dalam bentuk energy level diagram, kan makin bawah makin rendah energy level dia, makin tinggi juga dia punya energy level, sampailah energy level equals to continuum limit. Okay, so basically N adalah energy level and size of an orbital. Okay, lagi besar value of N, the greater the average energy of the levels, kan lagi besar the orbit, lagi besarlah energy level, lagi higher the value of N, lagi besar the average energy of the levels. And also lagi besar, lagi jauh dia punya average distance of an electron. Sebab kan bila let's say lagi besar the orbit, lagi jauh dia punya distance electron dia. Kan kalau kat sini n equals to 1, electron tu orbiting at the lowest energy level, dia sikit je lah distance dia. Tapi kalau let's say dia lagi higher the energy level, lagi besar lah electron tu nak tawaf the orbit. Okay, and therefore the larger or the less stable the orbital. So kalau electron tu berada di higher energy level, maka the electron tu makin tak stable, kan. And the principal quantum number have only integer values. Okay, principal quantum number hanya ada number bulat saja. Macam ni, sama ada 1, 2, 3, 4 up until infinity. Okay, so if you look at here, kalau let's say this is n, this is the principal quantum number ataupun dikenali sebagai energy level. Alright, so makin bertambah energy level, makin besar the orbital size, kan? Kalau let's say n equals to 1, the orbital size kecil saja macam ni. Orbital size for n equals to 1 kecil je. Tapi makin besarlah dia punya orbital size. Maknanya makin bertambah energy level, makin bertambahlah energy. Okay, tapi dari segi jarak elektron pada nukleus pun makin bertambah juga, kan? So if let's say you ada elektron dekat n equals to 1, kan jarak dia dekat saja dengan nukleus, berbandingkan dengan elektron di n equals to 3, jarak elektron berbanding nukleus sangat jauh. Okay, so this is the comparison of the energy level. The orbital size, it gets larger selari dengan energy level, and energy pun akan increase selari dengan energy level, and also the electrons from the nucleus pun akan lagi jauh from the nucleus kalau let's say energy level tu makin tinggi. Okay, the next part that you need to know about quantum numbers is the angular momentum or azimuthal or orbital quantum number with symbol L. Okay, tapi I lagi selesa nak panggil angular momentum quantum number. Basically, kalau you boleh dapat value of the L, you can know the shape of the atomic orbital, the type of orbital, and also the angular momentum of the electron. Okay, so macam mana you nak tahu L value? L value you can get it if you relatekan dia dengan N. N ni apa? N adalah energy level. Okay, so untuk tahu value of L, it will start from 0 until n minus 1. Okay, so ingat this equation untuk cari angular momentum quantum number. So there will be some letters akan di-assign to different numerical values of L. Kan Miss cakap kalau kamu tahu value of L, you boleh tahu the shape of your orbital and what is the type of your orbital. So if you get L value equals to 0, if you get L equals to 0, that means the type of the orbital ialah S. So S mempunyai shape spherical. So this is the shape of the S orbital. If you've got L equals to 1, therefore the type of your orbital is P. The shape of P orbital adalah dumbbell, and this is the shape of P orbital. Okay, if you got L equals to 2, that means the type of your orbital adalah D, and the shape of the orbital is cloverleaf, and this is 5 shapes of D orbital. And last one, if you got L equals to 3, therefore the type of the orbital that you dapat adalah F. Okay, tapi you hanya perlu nak tahu shape untuk S, P and D orbital sahaja. And going down, the energy increases. Okay, so untuk tahu more about this, we will move on to the next video and next slide. Okay, the angular momentum quantum number L ni, dia akan divide shells into smaller levels that is called as subshell. Okay, apakah shell dan apakah subshell? Shell adalah orbitals yang ada same value dengan energy level N. Subshell pula ialah one or more orbitals with the same N and L values. Basically, you dapat shells daripada energy level. Okay, you dapat subshell pula melalui angular momentum quantum number, which is macam mana nak cari L? It will be equals to energy level minus with 1. Okay, so the subshell notation that we have discussed on the previous slide, you have only 4 subshell notation, which is S, P, D and also F. Macam mana you dapat subshell notation ni? Melalui value L. Okay, so sebagai contoh, if let's say you dapat S subshell, if your subshells is equals to S, therefore your angular momentum quantum number is equals to 0. How do you get the angular momentum quantum number? Is from energy level n minus with 1. If let's say you dapat L value 1, makanya the subshell adalah P. If you dapat L value 2, makanya the subshell adalah D. If you dapat L value, nilai L kamu 3, makanya subshell kamu adalah F. Okay, so kat sini dia cakap the higher the value of L, the higher its energy level. Okay, so towards ke kanan makin bertambah kan value of L, therefore the higher its energy level, the energy will be increased from left to right. Okay, and therefore the subshells, dia punya energy dia akan increase as follows. Okay, from S, P, D dan seterusnya F. Okay, macam mana you dapat s.p.df? Dia akan ikut the value of L yang you dah kira. So you kena ingat ni ya, the value of L akan dapat subshell apa. Okay. Okay, L value, the value of L ni akan depends on the principal quantum number and ataupun N ni dikenali sebagai energy level. So if you ada energy level and you nak cari L, so the value of L will be possibly from 0 until lah to the number n minus 1. Okay, so and also the value of L ni dia ada subshell dia yang tersendiri. Okay, so for this subshell notation, dia ada specific value of L. Okay, and also the orbital numbers will be indicated by later. Alright, so for example, if your L value adalah 0, makanya subshell notation dia adalah S. If your L value adalah 1, makanya subshell notation dia adalah P. If your L value is equals to 2, that means your subshell notation is D. And also if your L value is 3, that means your subshell notation is F. For example, if we have energy level n equals to 1, that means the L value can only be 0. Kan kita dah bincang tadi, L punya possible integral value will be 0 until lah n minus 1. Since the energy level n equals to 1, so 1 tolak 1 jadi 0. So takkanlah dia punya L value 0 sampai 0 kan? So it will be just 0 sahajalah. Okay, so the L value can only be 0. So if you know, untuk 0, for the L value 0, the subshell notation adalah S. That means for energy level n equals to 1, dia hanya boleh dapat L equals to 0 and dia punya orbital adalah S orbital. Okay, untuk energy level n equals to 2, so you boleh dapat possible integral value untuk your L will be equals to daripada 0 sampailah ke n minus 1. So since the energy level n equals to 2, 2 minus 1 equals to 1, therefore your L can only be at 0 until 1 sahaja. Therefore dia akan ada dua subshell di situ, which is untuk energy level n equals to 2, since dia boleh dia punya L value dia boleh jadi 0 atau boleh jadi 1, therefore dia akan ada dua jenis subshells, which are S and also P orbitals. Okay, for energy level n equals to 3, therefore the possible integral value untuk n equals to 3 will be daripada 0 until lah ke n minus 1. Okay, since the energy level is equals to 3, 3 minus 1 equals to 2. Therefore, the possible integral value untuk L will be 0, 1 and 2. Okay. So, untuk energy level n equals to 3, the possibility untuk L value dia adalah 0, 1 dan 2. Therefore, you akan ada 3 subshells kat situ, which kalau 0 represent S orbital, 1 represent P orbital, 2 represent D orbitals. Okay, basically, kalau you nak tahu general shape of an orbital, you kena cari dia punya value of L. Okay, sebab value of L ni dia ada type of orbital atau type of subshells dia yang akan determine the orbital shape untuk orbital tersebut. Kalau if you have S orbital, then the orbital shape is spherical. Is you have type of orbital P, then the orbital shape will be dumbbell. If you have the type of orbital D, the shape will be cloverleaf. Okay, for this kind of things, the shape ni nanti kita akan draw together bersama-sama ya. Yang kat atas ni contohnya lah, if let's say you ada shell UK with the N value 1, makanya the L value boleh jadi 0 saja, and the subshells dia will be 1s. Okay, sebab ada S orbital kan. And if let's say if you have shell UL with the energy level N equals to 2, makanya dia punya L value dia boleh jadi 0, boleh jadi 1. Okay, so since 0 dia punya subshells adalah S, 1 subshell adalah P, and energy level dia adalah 2, makanya the subshells will be at 2s and also 2p. Okay, mana you dapat nombor 2 ni? Nombor 2 ni daripada N. Okay, S ni you dapat daripada L. Okay, L value. Next, if let's say you ada shell M with energy level 3, the L value will be from 0, 1 and 2. Okay, so 0 dia punya subshell S, 1 subshell dia adalah P, 2 subshell adalah D. Okay, so if you want to know the subshell notation for real untuk shell M, since dia punya energy level dia dekat ketiga, and then dia ada 3 possible L value, makanya you akan dapat 3s, 3p and also 3d. Untuk shell N, if let's say the energy level equals to 4, makanya the L value would be possibly from 0, 1, 2 and also 3. Therefore, the subshells will be 4s, 4 dapat daripada energy level, S dapat daripada L value. So the subshells will be for S, for P, for D and for F. The next thing that you need to know about the quantum numbers is magnetic quantum number M. Okay, value of M ni dapat determine the orientation of orbital in space. Macam mana you nak tahu value of M? Value of M will depends on the value of L. Okay, value of L pula depends on the value of N. Diorang ni relate tu dengan each other, related tu. So basically, value of M ni, dia punya integer value will be range from negative L to positive L. Okay, L pula tadi dia punya possible integer value dia ialah daripada 0 sampai N minus 1 kan. Kalau M pula is from negative L until positive L. Okay, so the number of permitted value of M ni akan indicates the maximum number of orbitals for a particular value of L. Contohnya, if let's say you ada L equals to 0. Untuk L equals to 0, the subshell will be S, right? S subshell. So, untuk you tahu ada berapakah orbital di dalam S subshell ni, makanya you kena cari the value of M. Okay, M kan is from negative L until positive L. So if your value of L is equals to 0, takkanlah you nak buat negative 0, 0, positive 0 kan. That means dia punya value of M dia will be just 0. So ada berapa value of M dia? Ada satu sahaja, walaupun angka dia 0 tapi dia ada satu sahaja value of the M kan. That means there will be only one orbital in S subshell. Okay. Next is, if your L equals to 1, if L equals to 1, that means the subshell untuk L equals to 1 adalah P subshell, kan? P subshell. So, untuk tahu ada berapakah orbital di dalam P subshell ni, you kena kira the value of M. So, the possible value of M for L equals to 1 will be -1 until +1. That means you will have -1, 0 and +1. So, ada berapa angka dekat situ from the possible value of M ni? Ada 3 kan? 1, 2, 3. That means there will be only 3 orbitals in P subshell. Next, let's move on to the L equals to 2. Untuk L equals to 2, dia adalah D subshell, kan? D subshells. So macam mana nak tahu ada berapa banyak orbital dekat D subshells? Makanya you kena tahulah M dia apa, which is possible M value dia adalah daripada will be from -2 until +2, which you will have -2, -1, 0, +1 and +2. Ada berapa angka kat sini? 1, 2, 3, 4, 5. That means you will only have 5 orbitals in D subshells. Apa kaitan number-number ni? Okay, nanti kita akan nampak benda ni kemudian, tapi you kena tahu dahulu macam mana nak cari magnetic quantum number and dia indicates what. Okay, actually berapa banyak value yang dia dapat tu adalah dia akan indicate berapakah orbital di dalam subshell of the L. Okay. Okay, tadi kita dah discuss your M value akan mengikut the particular L value. So, sebagai contoh, if let's say you ada energy level N equals to 2, makanya value of L for N equals to 2 akan possibly ranging from 0 until N minus 1. Kiranya, dia punya L value untuk N equals to 2, boleh jadi L dia boleh jadi L equals to 0 ataupun L equals to 1. Tapi sebagai contoh di dalam contoh ni, untuk N equals to 2 and L equals to 1, makanya L equals to 1 tu indicates 2p subshells. Okay. Macam mana you dapat dua kat depan ni, you dapat daripada energy level. Okay. Macam mana you dapat P subshell? Because you got it from L equals to 1. Okay. Di dalam 2p subshell ni ada berapa orbital dekat dalam 2p subshell? Okay. So nak tahu berapa orbital dekat dalam 2p subshell, that's why you kena kira dia punya M value. Okay. Nak tahu M value you boleh dapat daripada negative L sampailah positive L. So untuk N equals to 2, L equals to 1, makanya the M value dia will be -1 until positive 1. Okay. So bila M value dia adalah -1, 0, positive 1, so you ada 3 angka kat situ. 1, 2, 3 kan. So these 3 angka indicates 3 orbitals in 2p subshells. Kenapa tu? Sebab bila dia ada 3 orbitals, that means you ada 3 jenis lukisan untuk P subshell. Okay, nanti kita akan belajarlah macam mana nak melukis. Okay, so kalau let's say 3 orbitals into P subshell, that's why lah you ada 2px, 2py, 2pz. Lukis ni nanti kita akan belajar kemudian, tapi you kena tahu sahajalah macam mana you dapat 3 orbitals in P subshells is because of M. Okay, so basically from P subshell you will have 3 orbitals. Apakah 3 orbitals tersebut? Which is Px, Py, Pz. Nanti kamu akan boleh relate lah benda ni kemudian melalui lukisan. Okay. Okay, the last quantum numbers that you need to know is electron spin quantum number. S. Okay, electron spin quantum number ni dia ada dua sahaja value dia. You tak perlu nak depends pada N, L dan juga M. Okay, so basically you kena ingat value of S ada dua saja, sama ada positive half or negative half, because since electrons dia boleh turn clockwise or anti-clockwise. Kalau clockwise positive half, kalau anti-clockwise negative half. Apakah kaitan dia? Nanti you akan nampak kemudian, okay?